we will make a shift from the front end to the back end systems, and we will continue our journey of today with a LogZ. We started in the workload automation range, and now we want to shift to other really important products from our portfolio, speaking a little bit about the JobZ and speaking about the CheckZ product. And for this, I also invited some colleagues who know much more about these products compared to me. Welcome, Romy, Julian, and Daniel from the development team in order to give us some update about the products in the Lighthouse generation. First of all, thank you for finding the time to be here, and sorry for being a little bit late compared to our agenda originally. Lighthouse was a big program, and it was 2.5 years full of work. So I can imagine you're all very happy now that it is GA and that it is on its way to the customers. Is that? I'm not sure who is going to start. Romy, is it you going to start speaking a little bit about JobZ? So thank you very much. I don't want to spend more time by asking you nasty questions. I hand over to you, Romy. It's your stage. Thank you.
Okay, I now start sharing my screen, and you can tell me if you see.
Yes, we can see.
Okay,
Thank you.
that's good. Okay, I also welcome you to this next session of our Lighthouse feature presentation. In this session, as Niels already said, we are looking at our products Beta JobZ and Beta CheckZ. We want to introduce our new features in a live demo so that you can get a first impression of the progress of our products. Okay, on my first slide, I have shortly outlined the agenda of this session to show you what you can expect in the next hour, or a little bit shorter, since we have not so much time. Okay, we start with the product Beta JobZ, which first I want to show you how we have linked our BCom jobs with the corresponding EJM jobs, so that you can find the job output of the connected EJM jobs while you view the job information of the BCom job. The second feature we want to present to you today is a new command line interface that we have named EJMCP, and it enables JobZ users to use our file transfer functionality inside a script. The third item on our agenda will show you how you can use Beta JobZ to start and monitor jobs from inside Kubernetes. That is, from inside the cloud. So we introduce to you our K8S cloud connector for mainframe. The second and third feature will be demonstrated by my colleague Julian Klinkenberg, who has even more knowledge about those two features than me. And my colleague Dennis Filipzig will present the fourth feature, which we want to present you. This is a feature of our product Beta CheckZ, and he will show you how we have integrated Beta CheckZ into the modern scripting language Python. Thus, in version 8, you can write your CheckZ checking procedures using Python, which is pretty cool, I think. So now you know what to expect of the session. Let's start with the first feature. This is the linking between the BCom jobs and the EJM jobs that have been started by them. For a better understanding, I first want to remind you of the two ways that you can use to start an EJM job. The first way is by using our IWS interface. With it, you can directly pass EJM jobs from the scheduler to the JobZ starter task. That means without submitting a job on the mainframe. But not all of our customers use IWS as their scheduler. And even some who do sometimes have reasons to not use it and for all of their open systems workload. Therefore, we have another way to start EJM jobs. This is by using our batch utility B48 BCCom. You can use this utility in the exec statement of any ZOS job. We call such a job also a shadow job, because it is not only responsible for passing the job to the JobZ starter task, but also it is responsible for monitoring the job and reporting the return code of the job when it is finished back to the scheduler. So if you start EJM jobs with our BCCom utility, you have two jobs. One is the shadow job in ZOS that contains the BCCom step, and the other is the actual EJM job that has been started by the EJM agent on your Unix, Windows, SAP, or even the Kubernetes system. And since you have two jobs, there are also two job outputs that will be sent to and archived in Beta CheckZ. And so it is necessary sometimes to have a link between the BCCom job output and directly jump from there to the output of the EJM jobs or vice versa. So for both of our ways, we now have special views when you look at the job output that will help you with specific information about those two ways. For jobs that have been started by our IWS interface, we already have created a special view in a previous version of our product. This enables our IWS users to select and display EJM jobs using their IWS specific perception. For instance, they can see by which IWS application an EJM job has been started and on which workstation. For this purpose, the display of the job output in Beta CheckZ has implemented a special IWS section in the job information table of the EJM jobs that have been scheduled by IWS. But a prerequisite that you have to consider is that you have to set the JT-opt parameter items to yes in your IWS scheduler parameter file. With this parameter, IWS will add a special line to the job script that is passed to our JobZ STC. Yes, and this line contains IWS specific information that then can be passed by our product to extract IWS specific information. BCCom jobs, of course, are a little bit different. They have different requirements and different information that is relevant. So for BCCom jobs, it is not important by which application they have been submitted, but rather which EJM jobs have been started by the BCCom shadow job. For this purpose, we have created now a link in our new product version 8 between this BCom job and its corresponding EJM jobs. So when you view the output of the BCom shadow job in Beta CheckZ, there is now an EJM specific section in the job information table integrated. And this contains information about the EJM job or jobs that have been started by this shadow job. So now I want to show you how this looks in a live demo. So let's change to my mainframe terminal. So earlier this morning, I already prepared something for you. I scheduled 2 EJM jobs in AWS. And let's see if we can find them. This was today, and they were started by AWS. Let's see where they are. There. I named the jobs hot test job 1 and 2, and as we see, they are finished. And as you maybe know, you can use the line command V to display the script of such a job. Let's see what this job does. And here we see this job is a very simple Unix script which writes hello, and it lists a few processes with a Unix shell command PS, and that's it. And in the last line is something that we see because we in our AWS scheduler have set, of course, the item parameter to yes. And this is a line that AWS adds automatically if this parameter is set, and it gives us all the information that is necessary. Just let's look, there's my mouse. Yes. For instance, this is my application name. There is my workstation. So we go back, and as you already probably know, you can jump to the job output of a finished job by using line command 2. This brings you to our Beta CheckZ, and there you can view all job information available. For instance, you can see now that this job that I submitted was submitted to the DNS name of a Red Hat 9 machine, and the job was submitted by a user named Rodo. And if we look a little bit below this, you can then see the AWS specific section, which shows you all information that AWS provides us with. So for instance, the application where I have scheduled my job, the input arrival time, and the workstation. Yeah, and so this is what the AWS specific information that we have for AWS scheduled jobs. Let's go back to our Beta JobZ. And now onto our BCom jobs. For them, we have created something similar. I also prepared a job, a simple BCom job earlier this morning for you. I named it Launch Day 3. And it also has 2 steps, 1 and 2. Both steps start the B48 BCCom program, as you can see. And they contain small script, nothing really difficult. So let's submit this job. And then we go back to JobZ and look for our jobs. Finished. And there they are. 2 jobs because I had 2 BCCom steps, as you can see. And if we now again use line command V to view our script, we now see to this script now also a line was added, appended at the end. And this contains all the information about the BCCom job, the mainframe job that has started this Unix script. So very interesting. Let's see what you can get if you jump into the job output using line command 2. We are back in the job information table of this job, and we can see I have used the same agent on our Red Hat 9 machine, the same user. And look where our IWS section previously was. Here now is a EJM section, we have called it this, which shows you the corresponding BCCom job that has started this EJM job. And if you use line command S in front of this BCCom job, you can vice versa also see which EJM jobs this BCCom job has started. So you have quick access to everything. You can see how this looked. Oops, 1. Or how the BCCom job looked if you go back, or we simply go back to our job set. And yeah, that's what I wanted to show you for the first feature in my live demo. And I now turn over to my colleague Julian Klinkenberg, who will show you the next 2 features. Julian.
Thank you for your presentation. I will share my screen now. I hope you can see it.
Yes.
Our new command line tool called EJMCP will allow you to transfer files inside your basic EJM script. That allows you to do some pre or post processing. You can create new files, edit them, whatever you like. That's currently only supported for agent host transfer in both directions. You might know, the FTP step, and I have a small comparison between the FTP step and the EJMCP. It's not meant to be a replacement. The EJMCP is just an add-on. If you look in the second box where I call the command line utility, you might miss some parameters from the FTP step, and that are set as default values. In this case, something like BSA alloc is the default value I can use for a simple transfer. I'm transferring from a host file to a Unix file. You can select the transfer direction by your file name. You don't have to use your method for put or get files. The little Z double, the Z, I don't know the name of the next character, shows you, or
colon, I believe.
Yeah, I forgot how you name it, but
colon.
Whatever the 2 dots, Z2 dots, are used to tell the command line tool that it's an host file, and if there's no prefix, it's an agent file. So in this case, a Unix file. The charset conversion will always use the icon. So there is if you don't set CF or CT, the two parameters here, the JMCP will use its default value, so you won't use the trans tab files for your file transfer anymore. I've prepared a short live demo for some file transfers. You wondering, I'm using the VS Code Zoe extension, so I'm not so used to the terminals, and it's just easier for me to edit my files inside VS Code. The first job is transfer from a Unix file to a PS dataset. We will create it with those alloc parameters. Have our conversion from UTF-8 to IBM 1141, and I can show you the file on my Linux machine. It's just a cute little fox, and we will transfer it to our mainframe. You can see there is no PSFox dataset in my let's say directory on the host, and if we submit the job, you can even see it on the host that the job is running. I can full screen it. Might be a little bit small. It's already finished, so we should see after refresh that there's a new PS dataset. It's our Fox. Don't worry about the red brackets there. It's just the editor telling me there's missing the opening or closing bracket. The new line is also an editor thing. If you check it in your terminal, you can see that it's still 9 lines, same as our original Fox. Of course, you can transfer from host to agent, as I said earlier. There are some other parameters, for example, -F to overwrite an existing file I just created in this line. No trail will cut off any trailing blanks. Sometimes your host datasets are filled with blanks. To fill the whole line, you can remove them just in parameter. We submit this job in our Unix directory, sorry, wrong window, will be a new fox _dl txt, just created this time. If we look inside, it's the same fox we already saw here and on the host. You can also create new members inside your PO dataset. You have to put quotation marks around your file name because otherwise the shell will throw in syntax error. Maybe not all shells, but shells I have used will throw in syntax error because of the opening bracket, and it expects something else and won't just use this string as a string. So you have to put it in quotation marks. I mean, you have to put it here. Yeah. And as soon as we reopen our PO dataset, our well-known fox will reappear. You can, of course, download members from an PO dataset. It's just the same as uploading. Just switch the direction. The transfer direction is set by source and target files. So if your source file is on ZOS and your target file is on Unix, it will do a host to agent transfer. You look in our directory, there's a new Fox a new Fox appeared, our Fox DL2. It's the same Fox as in our previous transfers. The second topic will be our Kubernetes Cloud Connector. It just adds a new job type, just like remote or Java Batch or SAP to our list of different jobs. In the Kubernetes cluster is a new application. We have to install it there, but it's all described in the documentation. And this operator will wait for new requests from the agent. So everything is controlled by this Unix agent. Currently, there's no Windows support for the operator, the agent can create jobs or check the status and download the output after a job has been completed. Also, you have to note that the direction between the mainframe and the agent is bidirectional, so you both know of each other. The agent knows there's a mainframe, the mainframe knows there's an agent. But to the cloud, there's only one direction. The operator doesn't know the agent exists. It just waits for a new incoming request, so you don't have to open your firewall to anything. You have 3 different job types. The script job is just your default or your well-known EJM job, just not on Unix agent. It's run inside a container or job pod in your Kubernetes. Then you can package your binaries, your Java binaries or whatever inside a new container and also use them in your jobs. And the third type are Git jobs, where your job definition will be placed in a Git repo somewhere, and the operator in Kubernetes cluster will just download it and runs the job you have described there. We also have prepared a little live demo for Kubernetes. We have in our first job, it's a really simple script. It just echoes hello world and prints some environment variables. Yeah. You have to specify some parameters, for example, the namespace, which image you want to use, and your user is different than on Unix because it's your Kubernetes user, also known as service account, which needs writes like creating pods in your namespace, but everything like this is described in the documentation. If we run this job, we will not see much because it's just a really simple job, but we can check it in our Beta 48. And if we wait for it to finish, we can see the output. For example, our hello world will be written there, or the environment variables, like also the ones set by the agent will be available inside the job pod. The second job might be a little bit more interesting. I've simulated something like a job running, doing stuff and printing. And the step is completed. If we submit this job and switch to our terminal, we can select all our pods that are in the last, that's just to filter everything older than an hour. So we should see, it's this one, right? And we can just use klogs, the klogs -f. It's simple to tail -f to monitor. Oh, wait. Why is my alias not working? Oh, I miss. I was a bit slow. We can just rerun the last job because it took me some seconds. So we can see a real processing output. So this time just take this, K lux minus F. And now we should see our first print of Alpine job. That's our first line. I will switch now. Maybe we have to wait some seconds because I put a 3:30 to have enough time. I was still a bit slow in our first run, but we should see our steps being completed anytime soon. Yeah, it starts, and then we'll just print out our steps as we set in our script. That is the end of the Cloud Connector live demo, and the next presentator, Philip, will tell you something more about CheckZ and Python.
Thank you, Julian. I just need the presenter rights. Yeah, now I have them. You should now see my screen. Okay. I will now tell you the new feature in CheckZ with Python checking procedures. Let's start with why we did that. Python, specifically Python on the mainframe, has the advantage of being eligible up to 70% to be running on the ZIIP instead of general processors, which will save you money. And also Python has a huge library of different libraries, which will give you the possibility to access different kinds of data. For example, what you already can do with other checking procedures is process CSV data, but with Python you can also access, for example, JSON. I also have accessed Excel tables. So basically for every data format, there's almost always a library for it. Also, Python is a modern and widely used language. And what I mean here with simpler is basically a Python programmer already knows Python, and it's easier to program in Python a checking procedure instead of learning a new language and then writing the checking procedure. So how does it work? Basically what you will get from us is a CheckZ library in Python, which you can use to communicate with your CheckZ backend. And your checking procedure is just a normal Python script. And because it is a normal Python script, you can run it on the mainframe, but you also can run it on any other open system or in the context of a JobZ agent. The only requirement is you need Python installed with the CheckZ library. So now for the more interesting part, I will show you some examples. Let's start with a basic checking procedure. You can see my Python script that's here. And all I do is import from the CheckZ library, then start a check-in procedure here and exit with return code 0. I use here our new program, the B91Pi. I will explain more of its features with a later example, but for now, it's a program you can use to submit your Python checking procedures. Let's submit it. And you can see, you can then look at the output. Here's my job. And it writes an absum. And you can see here that my checking procedure has completed successfully. The time is also right. Now I will go back and show you the same checking procedure, but with the difference that now my checking procedure is a file in the USS. I will also submit that. Now I see the same absum with the difference that now the line script shows me what the script was that I executed. Let's go back. As a third example with the same checking procedure, I here have the added context of a JobZ agent. And here you can see it's just an X step with the line of your interpreter for Python, and then your Python check-in procedure. We can also submit that. It takes a little bit longer, but we should also see, yeah, return code 0 is great. And now you see here that it was submitted on my agent. Now I will skip to my 7th because it's my 6th. I wanted to go here because it's a check-in procedure with a little bit more complexity. But here you can see I define my key. I will get index to read from the database. If there's no key, I will create a new key, write it to the database. I now know that there already is a key, so I will read this key, the last key that is in the database. I will add to it and then write an S in a field and write the key to the database. Let's submit it. Return code 0. Here. And now here we can see that it has found a key and it has written a new key and completed successfully. So now what I have teased in the beginning, the features with our new B91Pi program, we give you the ability to write in data out or data in to communicate with the Python checking procedure. Basically, here you can read from the data in. You read from data in, which has hello from data in, and will print it from my Python program. So it will be in my std out. And then I will write to data out, written to data out. How fitting. So here, let's go into std out, hello from data in. And in my data out data set, I see written to data out. So the advantage of this is that you have with this the ability to better integrate your checking procedures in your workflow. I have here as an example a job with 3 steps. The first step produces any output, and then in the second step I will have my checking procedure, which will read the output from my first step. Then we'll write a key to the database, and then writes to my data out, and the data out can be used by the third step to further processes. Let's submit this again. 0. Select. Now we can see here in std out, this is the output of my first step. I can see in my upzone that my checking procedure has read a key and has written a key. And then I can see from the output from my third step. This is the output for my second step, which is the Python checking procedure. Let's go back. I only have one more example. Here you can see the advantage of using a library. I here use the CSV library that is part of the default Python library to process my CSV data. Here I will start a checking procedure, read my CSV data, and then look at what is written at the second position and write it out to my std out. So if I submit that again, here you will see in the std out is only DEF and 456. And in upsum, you can see that nothing was written, nothing was read, but the checking procedure has completed successfully. Yeah. So here, this is the data, and it only processed the second. Thank you.
Okay, then we are finished with this session. You are very far away.
You should hear me. Yeah. Can you confirm that you hear me? It's all on. Now you can hear me.
Better.
Okay, I won't let you go without having some question position. Thanks of all first for all your presentations, a lot of content. Let me start with the last one. Dennis, you has introduced the Python support for the JachZ. 2 questions from my side. You were saying in your PowerPoint that with that Python you can run 70% on the zip processors, so you have a potential cost saving with that method. Does that also mean it is 70% of workload that can be saved, or isn't that corresponding? Do we know how much really the standard CPU is released by such a move?
What I mean by that is 70% of the checking procedure, so the Python code, which will run, but the processing of the database, so it will still be running on general processors, but your checking procedure which has previously also run on general processors, you have the ability to run it, but that also depends on configuration. So I'm not.
Don't worry, I'm not going to quote you and to say Dennis had said that we have so much savings. Okay, so it is something we have to obviously try to find out either on customer side or in our laboratory how much CPU we really can save, because that is always an important aspect to our customers. If we can save CPU seconds, customers are very, very happy with that. And my second question for curiosity is to you. Python, of course, we decided, or you decided together with Christian, who is product owner and who is unfortunately on a sick leave. So if somebody at the screen is wondering why Christian Bressler isn't joining, sending greetings to you, saying thank you that you're taking over this show without his support because he's on a sick leave and ill. But you decided to go to Python because this is, of course, the more fashionable, the more modern, the more known programming language compared to our proprietary standard previously. Have you personally had contact to Python before? Was it something you knew already, or was it something you build up knowledge during the development process?
It was both. So I already knew Python as a scripting language, but I haven't used it to that extent. So I learned a bit more with previous knowledge.
Okay. So adventures everywhere, because I'm not sure if you listened to the previous sessions. I was asking everybody if they had knowledge on containers, if they had knowledge before, and they more or less all answered the same way, that yes, some we know, but we had a steep learning curve in exploring this. So it seems to be the same on the Python language. Romy, thanks for your presentation. As usual, you are familiar to probably all the visitors here because you have spoken on Technology Forum and so on. So not many questions left on what you presented, but just for confirmation, you have shown the eRMCP, the capabilities on the JobZ also, that we can transfer by having a call in a scripting environment. This is additional, right? So any customer who is thinking of using that, they don't have to be afraid that any option he had previously in the Symfony generation isn't working. We are not switching off any way to call EGM because we have invented now new ways, right?
That's right.
Okay.
Of course, the normal FTP step is still available, and you can use everything like before, or if you want to use it in a script, then do it.
Great. And I won't let you go without having a question to Julian. Julian, it's now you presented also a batch operator, and I know that you have been thrown into this project because the original ideas were designed by, my understanding, by Hendrik, who is sending also his regards to the team. Was it something that you were also familiar with before on the Kubernetes side for the Cloud Connect, or is it something that is completely new to you and you started when, I don't know who said, well, try to try to dig into that technology that you started from the scratch?
I was completely new to Kubernetes and cloud in general. I haven't done anything similar to this before, so it was, yeah.
And it's
sometimes was a bit weird, I guess. Not weird in a bad way, but just unknown stuff. It's like
okay.
always when you learn something new, there are some things that are harder than should be, I guess. And it's just not it wasn't my known field, so it's always a bit.
So Lighthouse is challenging quite a lot of us with new terms, new technologies, but we can confirm you all managed to complete these new assignments of Python, of Kubernetes, of scripting. I don't know, what was the biggest challenge for you, Romy, in this context? It can't be that everything was known already to you.
Keeping up to date with everything. Because I always have to know about all of our features and not only a small part.
Okay. So
because it's my product, if you want to say so.
I know what you mean. Keeping pace with all the developments of colleagues
Yes.
and other teams, because that is always a challenge, having a product suite that you get something new from BSA or from JobZ team and so on. So thank you very much for all your commitment, for all your work in combination with that first release of the Lighthouse program. I think a tremendous success. We are very happy what you have achieved. Thank you very much for presenting it today, and have a good day.